All right, our first percent yield problem. K2HPO4 is highly water-soluble salt that is used as a buffering agent, fertilizer, and food additive. It can be formed by the neutralization of phosphoric acid with potassium hydroxide, and then it gives us the balanced equation here. And it says 1.00 times 10 to the second grams of phosphoric acid. We know what that is. It gives us a formula, H3PO4, is reacted with excess potassium hydroxide. The final mass of K2HPO4 produced is found to be 1.63 times 10 to the second grams. What is the percent yield? Okay, so you have to know that this 1.00 grams of acid, it says it's reacted. You can also look at the equation, so we know that this is the reactant, which means that this is going to be theoretical. So we calculate the theoretical yield from this. And we're also given this 1.63 times 10 to the second grams. Okay, it says K2HPO4 is produced. So remember that this is our actual yield. Okay, so first things first, we've got to convert our reactant into the theoretical amount of product we can make. So our given is 1.00 times 10 to the second grams of phosphoric acid, H3PO4. Our unknown is how many grams of K2HPO4 we can produce. So how to get there? We've got to go from grams of phosphoric acid, H3PO4, into moles of H3PO4, into moles of K2HPO4, into grams of K2HPO4. Okay, so 1, 2, 3 conversions. Grams to moles, moles to grams, always molar mass. Mole to mole ratios, always coefficients. So we're going to have to do 2 molar masses, one for each substance, and mole to mole ratios. So the first one is 1 mole of phosphoric acid, H3PO4, equals blank grams of H3PO4. So that means we have 3 times hydrogen, 1 times phosphorus, 4 times oxygen. So that's 3 times 1.008, 1 times 30.974, and 4 times 15.999. So we got to multiply across, add these up. So that is 3.024. This is 30.974, and that one is 63.996. And then we add them to get 97.994. Okay, then we need to do the mole-to-mole relationship. Blank moles of phosphoric acid, H3PO4, equals blank moles of K2HPO4. We look at our coefficients for that. So H3PO4 is here, K2HPO4 is here. There's not a number in front of either one of them, which means that this is a 1-to-1 relationship. And then we do our molar mass of the K2HPO4. So we have 2 times potassium, 1 times hydrogen, 1 times phosphorus, 4 times oxygen. So that is 2 times 39.098. 1 times 1.008. 1 times 30.974. And 4 times 15.999. Alright, so 2 times 39.09. 78.196. 1 times 1.008 is just itself. So is the phosphorus, 30.974. And then 4 times 15.999 is 63.996. We add those up, and we get 174.174. Okay, so then our equation, 3 steps. We're trying to get from grams of H3PO4 into moles of H3PO4 into moles of K2HPO4 into grams of K2HPO4. And then we just need to cancel out our units, so that means grams of H3PO4 on bottom, moles of H3PO4 on bottom, and moles of K2HPO4. Alright, so substituting in, we've got 1.00 times 10 to the second grams of H3PO4 is given to us in the problem. Molar mass is always 1 mole of our substance. Then we got to get our molar mass of the phosphoric acid. That's 97.994. Okay, then we do our mole to mole ratio. Remember, these were both 1 to 1. So it's almost like you don't have to do it at all. 1 mole K2HPO4 over 1 mole of H3PO4. And then last but not least, our molar mass of our K2HPO4, 174.174 grams on top. And then we need the 1 mole of our substance on bottom. So 1 mole of K2HPO4. So math-wise, what are we doing? We're taking our 1.0 times 10 to the second, dividing it by the 97.994, and then multiplying by 174.174. Okay. Remember, when you put this number in the calculator, you need to put it in parentheses so that you don't make a mistake. And you get 177.739. Significant digits. You have 3. Remember, anything in front of the time sign counts. 5 exact for our mole-to-mole ratios, and 6. So our answer needs to go to 3. The 7 rounds the 7 up. This becomes 178 grams of K2HPO4, and that's the theoretical yield. So then we need to do our percent yield. Remember, you get the percent yield equation off of your formula chart. Percent yield is actual yield over theoretical. Okay, remember the actual is always given to you in the problem. So it's right up here. 1.63 times 10 to the second grams is our actual yield, and we just calculated our theoretical. So 1.63, oops, try that again, 1.63 times 10, second, over our theoretical that we just found, which is 178. Okay, so remember whenever you do these times 10 to numbers to make sure you put them in the calculator correctly with parentheses, or you know 10 to the second is 100, so that's 163 divided by 178. Oh, I apologize. I messed up our equation here. And for some reason it's not letting me erase. Remember, you got to multiply by 100. So after you get this, you need to multiply by 100. Okay. So really what you've got is 163 over 178 times 100. And when you do that, you should get 91.573. And then we need to do our significant digits. And both of our numbers go to 3 significant digits, which means this becomes 91.6% for the final answer.